Hi, good morning, good afternoon. Thank you for joining us today. I'm just going to give a few minutes, a few moments for the virtual room to fill up. I mentioned yesterday, I always find it exciting watching the numbers grow as participants join the virtual session. So hi again, welcome or welcome back if you were able to join us yesterday for our virtual event, Clean Hydrogen, Leveraging Bilateral Opportunities in Canada and Japan. Bonjour, bienvenue, konnichiwa. My name is Elizabeth Shirt, and like yesterday, I'll be your MC for this two-day event. As some of you will have heard me say, I'm the managing director of Globe Series, and my organization had the privilege of supporting the governments of Canada and Japan in organizing today's event. A quick reminder that this event is trilingual, and you're able to follow along in English, French, or Japanese. At the bottom of your screen, there's a language button, and that looks like a globe. Click on this to change your language. Pour ajuster votre langue au français, cliquez sur l'icône représentant un globe en bas de votre écran. Gengo, Nihon oni suruni wa, gamen kabuno, globu buton no, kriku ste kudasai. Before we start today, I want to once again acknowledge that I'm joining you today from Canada, from the traditional, ancestral, and unceded territory of the Coast Salish people. That's the Squamish, Tsleil-Waututh, and Musqueam First Nations, also known as Vancouver. For those of you who joined us yesterday, you'll remember we focused on policies and partnerships. We heard about the leadership of the governments of Canada and Japan on clean hydrogen, and we explored opportunities for Canada-Japan collaboration. We talked about how we can support the technologies that will increase the demand for hydrogen and how we can enable the development of hydrogen market supply chains and infrastructure. We talked about overcoming barriers, including bringing costs down, creating enabling regulatory conditions, and building up hydrogen economy literacy. And we heard about the potential role innovative partnerships with Indigenous communities can play to support access to sustainable energy development and to build community resilience. Today, we'll focus on innovation, markets, and trade by tapping into Canada and hydrogen's hydrogen market potential. And we'll showcase some of the exciting innovations that are already out there. We'll hear from companies small and large that are leading the pack in the hydrogen ecosystem. At the end of today, we'll also break into 2 networking rooms. So if you're looking for an opportunity to connect with others in the space, please stick around. I'd like to start us off like we did yesterday with a quick poll. So you can see now the agenda on the screen for how we'll be spending the next couple of hours together. But to just level set and see where we're at, I want to start with a poll. You should see that appearing on your screen now. And you can also see it in French and Japanese on the slide behind. So you can grab that pop-up and slide it from one side or the other so that you can read the poll in the language of your choice. I'll give you about 30 or 45 seconds to reply. We're hoping to understand what barriers you feel are being faced by players in the hydrogen economy right now. And you can feel free to pick all that apply. Is it difficulties understanding regulatory frameworks related to hydrogen? Difficulties proving technology on home soil? Are there challenges making connections and securing customers in new markets? Difficulties securing financing? Or difficulties with manufacturing capabilities or supply chain? Or are there other difficulties that aren't mentioned here? So I'll give you a moment to make a selection. I'll choose my votes here. You can choose more than one. And then we'll have a look at how folks on the line are feeling about some of those challenges. So it looks like the top being understanding regulatory frameworks, very interesting. Challenges around proving technology, so a good mix there in terms of some of the challenges that are being experienced. I want to kick off the first part of our programming now today with a panel conversation on tapping into Canada and Japan's hydrogen market potential. In this conversation, we have some excellent private sector leadership joining us. And so without further ado, I'd like to welcome to your screens, first from Japan, Mr. Fujimoto Yoichi, Senior Officer in the New Energy Business Development Department of Marubeni Corporation. Mr. Fujimoto, you can turn your camera on. Welcome. Also, Ms. Sasaki Yuko, Senior Associate, FC Mobility Promoting Group in the Next Mobility Development Department of Toyota Tsusho Corporation. And finally, from Canada, I'd like to welcome Rob Campbell, Chief Commercial Officer at Ballard Powered Systems. Welcome, all of you. Thank you for joining. So we're going to start off today with some opening remarks. I'm going to invite each of our speakers to just provide brief 3-minute snapshots to share with the audience a little bit more about your organization, projects you're working on, and what you're doing within the hydrogen economy. So without further ado, I'm going to start by turning over to Mr. Fujimoto. Please, 3 minutes. Looking forward to hearing from you.
Okay, hello, I'm Fujimoto. So I'm waiting, yes. So I'm Fujimoto from Marubeni Corporation, and I'm gonna introduce my company and also the business activity in terms of hydrogen. So next, please. So this is overview of company. Next. So my department belongs to the energy division and metal group, energy and metal group. Please, next. So currently the activity of the hydrogen and ammonia is covered 11 ongoing project we have. And the 6 from the top is the hydrogen, ammonia, and other new fuels. Next, please. Next, please. So one of the unique the demonstration project is ongoing in Japan, and this is distribution the demonstration from the green hydrogen to be stored in a metal hydride as a package to distribute to each residence and supermarket. So one of the feature is that metal hydride is nothing dangerous and can be transported easily through the available the existing network from the COP together with cooperation from the Hitachi company. Next, please. So this is additional the demonstration, and we will use the Fukushima Namie the hydrogen production facility, one of the world's biggest hydrogen production in Japan, and we will utilize this hydrogen to the residents and so on in the future. Next, please. So this is the target is decarbonization in the manufacturing factory of the car maker in Japan to use the dual fuel the combustion diesel engine and generator. Next, please. This is one of the biggest the bilateral governmental project between Japan and Australia to transport the liquefied hydrogen to Japan for the power industries. Next, please. This is one of the variant of the hydrogen utilization in Japan to use the as a fuel for the coal-fired the power plant in Japan. Next. That's all. So those things are still under the preliminary feasibility or the preliminary demonstration stage, and our goal is to make a serious investment in the nearest future for the operation of the project. And we are really looking for the commercialization very soon. Thank you very much.
Thank you so much, Mr. Fujimoto. Great snapshot of some of the projects that you're working on. Next, I want to introduce Ms. Sasaki Yuko to provide opening remarks. Ms. Sasaki, over to you.
Hello. Okay, hello everyone. I'm Yuko Sasaki of Toyota Tsusho Corporation, one of the Toyota Group company. I've been engaged in the hydrogen business for about 10 years. Toyota announced the Toyota Environmental Challenge 2050 in October 2015. It has passed 5 years, and we have been trying to achieve zero CO2 emissions and a net positive environmental impact to contribute to the realization of a sustainable society. I definitely believe that hydrogen is one of the solutions to achieve our goal. I'm showing Toyota Tsusho's hydrogen business scope from hydrogen source to market creation. Upstream is for hydrogen infrastructure. Not only hydrogen refueling stations, we are developing hydrogen cells to produce green hydrogen. Also, to expand hydrogen demand, we are developing user-friendly business model to get fleet operators, taxi companies, and bus operators so on to adapt fuel cell technology now, or at least near future. Please look at the lower stream. We are supplying fuel cell module and parts. And also collaborating with our partner, we build up fuel cell systems and provide them to OEMs to develop fuel cell trucks, buses, boats, and so on. By delivering mobility and providing fuel, we create fuel cell and hydrogen demand to accelerate hydrogen market expansion. I'm excited to discuss hydrogen market potential with other knowledgeable people in this session. Thank you.
Thank you so much. And last but certainly not least, Mr. Campbell, over to you for some introductory remarks.
Thank you very much, Elizabeth. I guess you're going to bring up the presentation. There we go. It's my great honor and pleasure to be on this panel today to talk to you about hydrogen. A brief introduction to Ballard Power Systems. We are a global company headquartered in Vancouver, Canada, and our vision is to deliver fuel cell power for a sustainable planet. And this has been our passion for over 40 years through the development and commercialization of fuel cell technology. Next slide, please. We are market leaders in our technology. We have powered thousands of heavy-duty vehicles. These are buses, trucks, trains, and ships around the world. We also do work with light commercial vehicles, passenger cars, backup power systems, and distributed power generation systems. Next slide, please. Our specialty are proton exchange membrane, or PEM, fuel cells that are fueled by hydrogen to produce electricity. These are most commonly used for mobility applications. And we've invested heavily and continue to invest in research and development and now volume manufacturing as our products are needed to meet growing global demand. We are vertically integrated and lead the market in terms of durability, lifetime, reliability, and cost. Next slide, please. And finally, we are hard at work to accelerate a carbon-free world with hydrogen and fuel cells. We are focused on the following 4 priorities to help drive mass adoption of zero-emission sustainable power this decade. And this is effectively around continuous technology improvement through R&D, through product industrialization to scale up the commercialization of the technology, ongoing application integration with our customers and partners to allow the easy use of our technology, and finally, market engagement through ecosystem development, where we partner with other companies to make it easy to apply hydrogen, so to provide a total solution to the marketplace. And so we look forward to discussing this further on the panel. Thank you.
Great. Thank you so much, Rob. So now we get to the fun part. We get to have a discussion and ask a few questions. So I want to start off just by talking about how do we scale? What's the opportunity to really scale up? Yes, technology, yes, production in terms of commodity, but trade of commodities, of hydrogen as a commodity, and trade of technologies. And maybe Ms. Sasaki, I can start with you. What are some of the key lessons that you've learned in your career that we could think about scaling up trade? How do we scale up the trade of these technologies and the commodity? And how might that be applied to collaboration between Japan and Canada?
Okay, thank you, Elizabeth. As one of the Toyota group company, we are highly expecting to expand the fuel cell applications, especially fuel cell automobile. To realize and accelerate that, we are developing hydrogen value chain, which can help the expansion of fuel cell application. And also in near future, we want to establish a system to supply green hydrogen. There is no royal road to expand hydrogen. Of course, you know that. And by country, by area, by product, etc., it would be important to establish the appropriate supply chain. For example, decentralized hydrogen distribution network might be cost competitive to centralize bulk production and delivery for a certain volume of hydrogen demand, I think.
Thank you, Yuko. Rob, I'll go to you next. Thoughts on lessons you might have learned during your time with Ballard about opportunities to scale up trade, and how might that be applied to Japan-Canada collaboration in particular, as well as more broadly? Oh, classic line of now it's 2021. You're muted.
Thank you, Elizabeth. To scale up trade, we have to scale up business, and so the key lesson that we learned was to go after those initial applications where the value proposition is stronger, where the commercial readiness is better. And so that's why we're focused on heavy duty applications, which typically involve fleets. Fleets of buses, fleets of trucks, trains going from point to point. So we can plan in parallel the deployment of the fueling infrastructure to create a scale application. And with the fleets, it gives predictability around the demand of the hydrogen required. So it allows the hydrogen supply partners to plan the delivery of that fuel in quantity. And so we just have to replicate that model. And I think what we've seen is now many locations, many cities are following this practice where they're starting with like buses for urban transportation, but now moving into other applications such as trucks, trains, and ferries. So by having a targeted approach, combining it with fueling technology, we can get going on this journey.
Great. Thank you so much, Rob. Yoichi, I want to ask you the same question. What are you seeing as some of those lessons? What do we need to do to scale up the trade opportunities with either the commodity or the technologies?
So I have the several the idea or the opinion, but if I focus on the some scale up or the others, I agree with partly agree with Mrs. Sasaki that there are some the opportunity, specific opportunity for the scale up and large transportation hydrogen and large the massive utilization of the hydrogen, but also we also better to focus on the centralization or localization usage of hydrogen and local transport, as I explained as one of my activities. So we better to pursue the both approach.
We heard that yesterday as well in some of the conversation, that we need to be looking at stimulating, those technologies and projects that represent the demand, as well as building out the supply chain and the infrastructure pieces. I wonder, we're seeing some questions coming in the chat already, which is wonderful. And please, to our audience, feel free to use that chat and put your questions forward. So we had a couple of mentions, of course, and the opportunity to use fuel cells in vehicles. And so a question coming in from the audience, what's needed to support or stimulate deployment of vehicles in a particular area? So I wonder maybe, Rob, we could start with you on that in terms of, what do you do to stimulate the local deployment of those kinds of vehicles?
So first off, I mean, we look at fleets such as buses, they run many hours a day. So the biggest cost is the fuel over the life of the vehicle. So we must have affordable and green hydrogen as an eventual outcome. On a practical basis, we see other sources of hydrogen coming to the market that may be affordable but not fully green. So we may have to be flexible as well with blue hydrogen or other forms of hydrogen that get us to that end state. But number one, unless we have affordability, we don't get adoption. So that'd be my main message. And that at the same time, I've been amazed at the interest and the demand to do projects. People want this technology today. So I can assure the hydrogen providers that this is a good business to enter. So if you're thinking about investing, now is a good time to help scale up this industry.
Great, thank you. Same question to you, Mr. Fujimoto. What does it take? Other thoughts on we've heard the importance of getting the cost down and being flexible in terms of the source of fuel. In your mind, what's needed to stimulate deployment of vehicles in a particular region or area?
So I'm not pretty sure that I'm knowledgeable enough to in the field of the vehicles, but I concentrate on the creation of the other demand of the hydrogen, especially in Japan, such as the houses, residents, local area, and also for the power generation industries in the near future. So if I talk about the vehicles, maybe it is a common sense that the fuel cell vehicle, like the Toyota Mirai second generation and others for the private passengers is not good enough, and heavy duty vehicles is one of the promising the opportunity for the hydrogen generation production.
Great, thank you. And Ms. Sasaki, other thoughts on this? What's needed to stimulate, local or regional deployment of technologies that would use hydrogen, like vehicles?
Yes, as everybody recognized that the total cost of ownership is very high for fleet owners if we own hydrogen vehicles like heavy-duty trucks and buses. So the mechanism or system to provide a service like a one-stop service, like a $1 per mile service for fleet owners to own or lease hydrogen vehicles, and then they can choose. They have the options, opportunities to choose either they want to go to EV or to go to the fuel cells. So that's very important to form the mechanism to provide the a user-friendly service.
Great, thank you. We talked a little bit about end use demand. I want to flip to that supply piece and thinking about, global trends in hydrogen markets. What are the opportunities or the drivers that are helping Canada and Japan produce their own clean hydrogen? And I know, Rob, you mentioned sort of those drivers in terms of the carbon intensity, the green versus blue source. We did have a question in the chat about is the color important, or is it about the carbon intensity? So does the source matter? But I wondered, and maybe Mr. Fujimoto, we could start with you, thinking about what are those drivers, what are those market opportunities to produce clean hydrogen in Japan, and what are the aspects that might lend themselves to collaboration between Canada and Japan in terms of and the production of clean hydrogen?
So it is obvious that in Japan that we are lacking of the clean hydrogen or the least carbon intensity hydrogen, or what we call green hydrogen. So as I explained at the beginning, that we have the new green hydrogen production facility in Japan, starting operation almost a year ago, and this is one of the only big supply source of the green hydrogen in Japan. But this facility belongs to the government, and we cannot use freely for the commercial purpose yet. Therefore, I really think that there is a lot of the business opportunity through the collaboration with Canadian partners.
Great, thank you. Ms. Sasaki, I see a question coming through for you in terms of that Toyota is a manufacturer, of course, of vehicles in Canada. Wondering about plans for manufacture and export of hydrogen vehicles to Canada, what that looks like, both in Japan and Canada. What are the growth or the manufacturing plans there?
Very good question, but unfortunately, I belong to Toyota Tsusho, so I cannot represent the Toyota motor itself. So it's a quite tough question to answer. I need to check with Toyota motor actually.
Fair enough, my mistake, but question coming through in that regard. So let's shift to you, Mr. Campbell, in terms of green hydrogen, and it's important to Ballard. We talked about that that notion of being flexible, blue versus green, and a question around cost, carbon intensity. Can you speak to some of those opportunities and trade-offs?
Yeah, so we have to recognize that the overall driver is to reduce the carbon output in order to address climate change. There's also a driver with the use of fuel cells and zero emission vehicles to reduce pollutants in urban environments where we use the vehicles to have less pollution for healthcare reasons. But if we focus on the carbon side, ultimately we need to get to that sustainable situation where we do not have the negative effects of climate change impacting us. When do we get there? Hard to say. How fast do we get there? As fast as possible. But at the same time, we have to be practical, as I mentioned. And with that interest, there's many companies coming to the market now with carbon capture, carbon sequestration ideas. So it could help because there is a timeline to create the renewable energy generation, create the green hydrogen. And so we don't want to wait. We want to decarbonize however we can, as fast as we can, and deploy this technology as well. And I think I saw another question, which is saying, when can we start using these vehicles?
Yeah.
You can use them now. We have, Toyota Mirai vehicles at our head office in Vancouver. We have a fleet of them. We also have buses deployed around the world. We have trucks operating around the world. Yes, they're in small volumes, but we're already on this journey. And surprisingly, the value proposition around buses is one that can work today. We have people providing us hydrogen costs that are very attractive, and you can have a zero emission product that works just great today.
Fantastic, thank you. Ms. Sasaki, I'll come back to you in terms of, you had mentioned about opportunities around mining, and we do have a couple of questions coming in that regard. What would hydrogen fuel cell mining equipment look like? Is that an option on remote sites? And so I wonder if you could talk a bit more about that example.
Sorry, I couldn't get your question clearly. So can you give me the more
For sure, yeah. You mentioned about the opportunity for mining equipment for hydrogen.
Mm-hmm.
And so the question was, what might that look like in terms of mining happening at remote areas? So what about, what would that opportunity look like if we looked at hydrogen fueled mining equipment?
Okay, so about the mining equipment, all right.
Mhm.
Okay. So not only for the mining equipment, like a large scale, like heavy duty trucks and mining or boats, those consumes a lot of hydrogen or energy or fuel. So that there might be the opportunity to for the fuel cells to as a powertrain for these vehicles, because remote areas, it's very difficult to carry gasolines or to remote areas, but the hydrogen, we might be able to deliver a liquid hydrogen or metal hydride or other unique fuel forms. And then, so in that case, hydrogen might be a good opportunity, a good option to fuel these heavy duty equipment, I believe.
Great, thank you.
I could
Please.
just maybe
Yeah.
supplement that, Elizabeth. One of the projects we're working on is by Anglo American. So what we understand from Anglo American is they're going to build large solar farms right at the mine sites, and they'll use that renewable energy to produce the hydrogen that can fuel the vehicles. So where the mines are, in many cases, South Africa, Chile, Australia, they have excellent solar energy resources and can actually generate the electricity at very low costs. So this is a new development that is being trialed now by Anglo American in South Africa.
Thank you so much. Great intervention. Did Mr. Fujimoto, did you want to add anything to this discussion around the use of hydrogen for some of that kind of equipment?
Yes. So my company is also working on some other application of the hydrogen in Japan, and maybe not only in Japan, but the application is that to use as an energy storage system of the hydrogen, as an alternative, the battery, lithium-ion battery. So the cost of the lithium-ion battery is relatively high and cannot reduce so easily. So therefore, in Japan now, we are thinking or try to develop the technology together with Japanese manufacturers, and to use hydrogen as an energy storage from the power grid, for example, to reduce the oversupply of the power. Or if we talk about the very poor the power grid infrastructure, especially in the Hokkaido area. So they definitely need some power storage systems if they introduce more the renewable power from the solar power, wind power, and so on. Otherwise, those unstable power from the renewable the generation systems occupies and destroys the total power grid network. So of course, also this is very serious problem, and we have to think about it.
We've heard a number of references, of course, to the criticality of driving costs down, right, and that being really important for uptake. And we had an earlier question come in through the chat about what does affordability look like when we think about these technologies, whether it be a passenger vehicle, a truck, a bus. And so I'm interested to hear from you, Rob. What does affordability mean, and what are the key mechanisms? What are the key steps we need to take, and perhaps that's role of government alongside private sector to get to that affordability place?
Great question. Thank you, Elizabeth. So when we look at these applications, we think about the total cost of ownership or life cycle cost. And this is how the people using these vehicles think today. Like they say, what's the cost per mile or cost per kilometer over the life of the vehicle? So one of the things is then to look at those costs and define affordability on that basis. And when we do that, we take into consideration the cost of the fuel, the cost of the technology, the cost of the service. And affordability is providing the same value, like transporting your goods or transporting the people with zero emission at a cost point that's equivalent or less than the diesel technology. And that's our mission, to aggregate all the pieces together and deliver that value proposition, which we believe is totally achievable. Now, in addition, the new technology can be more expensive to produce at the beginning. So we have to overcome that through creative financing mechanisms. And this is where we're deploying solutions such as, vehicles as a service. So we can go to the customer and say, listen, instead of buying that fuel cell bus or truck, you go with a variable plan where you pay for it over the life of the vehicle through leasing or through per kilometer structure. And this approach will be the way it gets done, in my opinion, for scaling up the business. There'll be a partnership with financial providers to do this. And of course, new technology, commercial banks need to get comfortable and confident in the technology. And so we see programs that are helping with this. One in particular is the European Investment Bank. We have a project we're working on with them where they will provide 50% of the financing. There'll be an equity component, and then there'll be a relatively modest component to attract commercial banks. And through that, the commercial banks can get the experience and the comfort, and then they'll be ready to invest in the next project at a much higher level, and then we'll see the growth.
Thanks for that. Super helpful. I want to put Mr. Fujimoto, same question to you. What does affordability look like, and how do we get there? Are there financing mechanisms? You talked about a lot of the projects that you're working on the demonstration side. How do we see those become affordable and scale up?
So it is still the difficult question to answer, but if I talk, then of course, if we pursue the very large, serious the project for the large transportation, the green hydrogen from the other countries to Japan, we have to involve the government and also the governmental financial institution as well, and to try to create the financial mechanism for that purpose. Firstly, we need some sort of the guarantee from the government, as we obtained from the government in the field of LNG 30, 40 years ago. So we, as a beginning, the first delivery of the large-scale LNG from Australia to Japan, for example. So we or bank definitely needed the government guarantee for the project. Otherwise, it doesn't make sense.
Thank you so much. I wanted to go back to Ms. Sasaki, just thinking about, again, the opportunities around collaboration between Japan and Canada from a trade perspective, from a technology perspective. What do you see as some of the best sort of opportunities to collaborate when you think about working with colleagues in Japan?
All right. So as you may know, everybody maybe recognize that the energy cost in Japan, like electricity and gas cost, is very high. So produce hydrogen from renewable source like wind power and solar power, even using that kind of energy, it's very costly to produce hydrogen in Japan. But the technology itself, in Japan, there are like quite lots of new technology. So like engineers and their professors are really working hard to create a new technology to achieve the certain goal to produce hydrogen at a certain cost. I mean, the lower cost than now. So I want to, my expectation is collaborate is a technology in Canada and Japan, and we maybe we can test or demonstrate in Canada and bring that technology back in Japan, and then assuming the like a renewable energy cost down, then we can create a renewable, I mean a low carbon hydrogen in Japan in near future.
Same question to you, Rob. What's the most exciting opportunity you see in terms of the collaboration between our jurisdictions?
So, I think, Japan has been a leader in policy and in championing hydrogen and fuel cell technology for some time. Canada in December also announced its hydrogen strategy. So I think it's very exciting to see the alignment in the thinking between the two countries. And the two countries have had a longstanding, very good trade relationship. So I think the point that was made is maybe Canada could be an early adopter for our technology, because we have such enormous amounts of renewable energy all across the country. And we could use that to deploy the technology, scale the production, and hopefully even export that energy to Japan at some future point, so that would enable low cost affordability in Japan as well. And it's a very exciting frontier out there. We do have recent examples of customers now coming to us wanting to do projects in Canada. So I think what we need to make this happen is also, as I mentioned, financing. And I know Japan is very strong at this type of financing. They take a long-term view. So I think between the technology and the financing and the affordability of energy in Canada, we have great opportunities. So that excites me. Thank you.
Me too. I love hearing about these opportunities. Yoichi, same question. What's the most exciting opportunity for collaboration that you see between our countries?
So firstly, I'm always open or welcome to the proposal from the Canadian colleagues, and then if I talk specifically that the market of the fuel cell in Japan, maybe there are some fuel cell manufacturers also in Japan, and I'm not so much familiar with the market in the fuel cell vehicles in Japan. So if I talk about the other demand, the power generation sectors, the major Japanese potential utilities, electric company to use the hydrogen or the ammonia is one of the biggest opportunity in the coming 10 or 20 years. So, but a lot of the proposal for the collaboration we are supposed to receive from all over the world, where the very low cost renewable energy available, and but the problem is that the transportation. So it is not so easy to collaborate and to establish the result or deliver the result soon. Mm-hmm. So then maybe I'm not also familiar with the Canadian partners for that purpose, but still there is some opportunity. But I would like to remind that all the major Japanese utilities receives a lot of proposal from around the world, and maybe yes. Canadian partner also try to penetrate in this demand, and so I would like to support something.
Excellent. So talked about some opportunities. I wanted to shift again to thinking about some of those barriers. We talked about cost as a barrier to scale up. What are some of the supply chain barriers that we're seeing? We've seen a couple of questions in the chat related to pipeline constraint and technical potential constraints around infrastructure. Mr. Fujimoto, you talked about the transportation being an issue. So I wonder, maybe I could start with you, Yuko. What are some of the key sort of supply chain infrastructure constraints that need to be overcome to be able to move our hydrogen economy forward? You're just on mute, Yuko.
Okay. So thank you, Elizabeth. As Mr. Fujimoto mentioned, transportation is one of the biggest barrier to achieve the hydrogen value chain, cost competitive hydrogen value chain. So we need the some other measures or things to overcome such barriers transportation problem. And also the hydrogen production is the other items, because the as I mentioned, the energy cost to produce hydrogen is one of the big factor to make the hydrogen cost higher. So we need a more cheaper or reasonable, affordable energy source to produce hydrogen. So, but location to location, country to country, the situation is different. So we need to set up the suitable, appropriate hydrogen value chain which suitable for this location, that location. So as I mentioned, there's no royal road to achieve such a supply chain. So we need to create a suitable supply chain in certain area or cross-border supply chain.
Rob, same question for you. When you think about some of those supply chain or infrastructure challenges, what comes top of mind beyond the cost factor, technical or otherwise?
So slightly different perspective. We have customers asking us for like a fuel cell truck or a fuel cell vehicle. This is quite disruptive to the suppliers who are providing these solutions now. And there's a lag time for them to learn about the technology, to integrate the technology and apply it. So I think that's not so much a barrier, it's just that there's the time to market. And the good news is companies now see hydrogen as a realistic option. Most of them started with battery solutions, but now they're migrating and looking at batteries with fuel cells, because every fuel cell produces electricity, so it really goes well with a battery electric platform. And that behavior is now accelerating, but in many cases, we just don't have enough vehicles for the customers to use yet. So our request is to all those OEMs out there, work with fuel cells, and that'll address that issue.
Fantastic. We are coming to the close here. We got about 3 minutes left. So I want to give each of you a chance sort of for a final remark. What would you leave our audience with? What would be sort of the number one message? We're all proponents, champions of moving forward with a hydrogen economy. We see great opportunities to collaborate between Japan and Canada. What would be sort of the top message you'd leave with the audience? That might be an opportunity to collaborate, a barrier to overcome. What's the top of mind message that you'd love the crowd to leave with? And maybe Rob, I'll start with you, and then Ms. Sasaki come to you next, and then Mr. Fujimoto to have the final word. But Rob, over to you. What would you leave our audience with?
So for our Japanese friends, we'd like to do more business with you. We have world-class technology, and we want to make a difference as soon as possible. So please let us help you.
Wonderful. Yuko, over to you. What would you leave our audience with?
Yes, everyone, hydrogen and fuel cells are not future technology. These are now on the market. So please try to have a more interest in that technology.
Love it. And Mr. Fujimoto, last word to you. What would you leave our audience with in Japan and Canada and internationally?
Yes, I have a lot to talk about, but the time limited, and so the Prime Minister declared the zero emission in 2050. Then the whole industry in Japan is now to think about very seriously what to do. Then the every day or the major newspaper, they report that the target by company or the industry to the decarbonization, zero emission. Then the hydrogen is one of the key issues for as a solution. So therefore, the potential demand is getting bigger and bigger every day. So I'm quite open, and please contact if you would like. Thank you very much.
Wonderful messages. We want to do business. The future is today. The opportunity is now, and we have the production. The fuel source is there. Perfect. Perfect combination. Thank you so much, Rob, Yoichi, Yuko. Thank you for joining us today. It's been such a pleasure chatting with you, and you're free to turn your cameras off and take a breath and take a drink as we move on to the next part of our program. So thank you very much. Have a wonderful rest of your day.
Thank you too.
Wow, what a great conversation. Coming up next, we have the innovation showcase component of the program, which is going to be really exciting as well. But before we jump into that, in just a couple of minutes, I am going to welcome you to just take a short break, grab some coffee or a snack if you'd like. You can stretch your legs. You can take a little bit of a stroll around, because I know 2 hours is as interesting as this is. It's a long time to sit and watch your screen. In the meantime, for those of you joining us either new today that weren't here yesterday or that were able to join us yesterday, take a minute to use the chat and share some of the hydrogen related projects that you're working on right now. I know we saw yesterday a number of folks sharing some of the work that they're engaged in. So now would be your opportunity to interact with one another and share some of that information about the projects you're working on, whether those be here in Canada, where I'm joining from, perhaps in Japan, or I know we have individuals joining us from even further afield, from the US, the UK, Latvia, Mexico, Colombia, Germany, and much more. So we'd love to hear what you're all working on. So please get busy in the chat and feel free to share some of that. And otherwise, take a break, take a sip of water, and we'll be back really, really shortly to get going with our innovation showcase in just a moment. So I'm watching to see what kind of projects are on the go. Now, don't be shy, because I know lots of you are working on your own projects in these spaces. We want to hear all about them. All right, well, maybe in the networking spaces, we'll get a chance to hear about some of those. We are ready, though, I think, to move on to the next part of our program. And that is the Clean Hydrogen Innovation Showcase. So why don't we get started with that? And of course, you can still feel free to use the chat to share those projects that you're working on that we want to hear all about. So you'll see from the agenda, the Innovation Showcase coming up next for the next few minutes, designed to give you a snapshot of the innovators in Canada and Japan who are advancing clean hydrogen technologies and innovation where they work and live. So we're going to hear from 6 innovators total, who'll give you a peek into the work that they have going in this space. We'll first start by hearing from a group of 3 innovators, and then we have 3 expert commentators who'll join us after that first set of presentations. Francois Gerard, he's chairman of the Canadian Hydrogen and Fuel Cell Association. We have Mr. Kato Se, head of Climate Change Projects Office in the Climate Change Policy Division, Global Environment Bureau of the Ministry of Environment in Japan. And of course, Deanna Horton, senior fellow with the Munk School of Public Policy at the University of Toronto. So we'll have them joining us shortly. But before we do, and those commentators will join us to share about their perspectives on the innovations we're hearing about, what stands out as exciting and promising for them. But before we go to our commentators, we want to hear from some of our technology developers. So first off, our first presentation, we have Jeff Grant, who's principal with Zen Energy Solutions. And so Jeff will have about 5 minutes to present the technology and the company Zen Energy Solutions, what he's working on. So Jeff Grant, you're on.
Great, thank you very much. Yeah, I appreciate that, Elizabeth. We're very happy to participate in this great session, and yeah, looking forward to hearing some of the other presenters as well. If you could jump to the next slide. So I just wanted to share a little bit about our company. We are not a technology provider, though I do have a background in the fuel cell sector. I've spent about 20 some years now. 15 of those were at Ballard Power Systems, where I worked with Rob Campbell and some of the others. But we have broken off about 5 years ago to set up a consulting company. About 80% of the business for Zen is in the hydrogen and zero emission transportation sector. We like developing projects, and we've been fortunate enough to help our clients raise about 108 million in total over those 5 years in non-dilutive funding to deploy clean energy solutions. And our consulting practice, we have a good mix of technical and business acumen. We've got good project management skills and some PMPs involved in the team. So we really like to guide projects from the inception to the implementation. And as any business grows, you sort of coalesce around, what are some of the key pillars, the key projects that you focus on. And the key pillars for us really have broken into these 4 pieces. We do a lot of strategy work. So we were the lead author in the national strategy that was released in December. And I'll talk a little bit about that in a later slide. We did the strategy for British Columbia, for the Maritimes. And we've done some specific sector strategy work for example, the pulp and paper sector and some others. And now it's kind of interesting. We're actually, as the interest in the hydrogen sector is heated up, we're actually involved in a lot of now M&A activity with clients, helping them with their due diligence. So that sort of falls under that pillar. Project development is a big piece of what we do, and that's really forming partnerships, building consortia, as I mentioned earlier, doing grant writing, so we can find non-dilutive funding to accelerate these projects, so bringing private and public money together. Project management, so the meat and potatoes of executing work plans, budgets, and schedules, we do that work. And then fleet transition planning, this has become a big part of our business as well, and that's helping fleets, primarily in the transit sector, plan to transition to a zero emission future. So typically that's a mix of both battery electric and fuel cell electric buses, but we do route modeling and some analysis to help them come up with that plan. Next slide. I'll just go through here really quickly. So we started out as a very small consulting company. It was Sabina Russell and myself, and since then we're now at 10 people, and we hope by the end of next week we'll be at 12. Yeah, we're quite happy with the growth. I won't go through each of the people here, but we do have a very good team on both the commercial and on the technical side of things. Next slide. So this is an important piece that I wanted to cover off. We did work with NRCan as the lead author for this national strategy. And we're very, very proud to be part of that and to see it released in December of last year. NRCan had been working on this for some time. We consulted 1,500 different stakeholders, and really tried to identify where hydrogen's role would fit in Canada's economy. What we learned was that hydrogen by 2050 could essentially provide 30% of the fuel requirements, the energy requirements for the country. 350,000 high quality jobs, a $50 billion domestic market, and hydrogen would have the ability to solve about 25% of the CO2 emissions problem in getting us to a net zero situation in 2050. So, it was a good process. We learned a lot going through this, and yeah, we were quite happy to get to the point where this was released in December. Next slide. I think I may be getting to the end of my 5 minutes here. In terms of project development, I'll just give a good example. Some of you who participated in earlier sessions may have heard about the Azatec project. This is an example where we worked with partners from the beginning, Ballard, Dana, Freightliner, Trimac, Bison as truck operators, and developed a project for 2 Class 8 trucks over 700 kilometer range, which meant over 100 kilograms of hydrogen on board. We expect these trucks are going to be delivered in the second half of this year and begin an 18-month deployment at that point. Our role in this is project managers. So we're supporting the Alberta Motor Transport Association. AMTA is they're the applicant who received funding from Emissions Reduction Alberta and NRCan. And we support them in terms of reporting and managing the scope of work and all the different partners. Next slide. And finally, I talked about this already, but we provided transit planning services for 3 different agencies in California last year. Sunline Transit in the Coachella Valley, Fax Transit in the Fresno area, and the Golden Empire Transit District. So what that meant was again looking at the current fleet, the duty cycle for their routes, and determining what the rational approach would be to get them to a zero emission fleet sort of paradigm at the 2040 timeline, which is what's required in California under the California Air Resources Board. So we were able to put that together and have those 3 ICT plans, Innovative Clean Transit plans, released last year. So that was I guess a big lift from our side, and we're proud to release those. I think that's it from my side.
Awesome. Thank you so much, Jeff. Really appreciate the snapshot on Zen as not a technology provider, but a solution provider nonetheless, supporting in a number of different ways. So thank you so much. Up next, we have a presentation from Mr. Kuriyama Tsunekichi. He's Chief Promoter of KPR, Kawasaki Recycle Business, with Showa Denko. So over to you, Mr. Kuriyama. Thank you for joining us.
おはようございます。昭和電工の栗山です。これから発表させていただきます。我々はですね、2015年、日本の環境省の水素実証プロジェクトで参画しております。その一つのプロジェクトでございます。かいつまんに言いますとですね、家庭から出るウエストプラスチック、廃プラスチックからクリーンな水素を作っていると、そういうプロジェクトになります。日本ではですね、家庭から出るプラスチックと包装容器をですね、市民が集めて自治体が回収して、これをリサイクラーに持ち込むと。自宅処理業に関しましては、包装容器を出した会社が負担すると。そういう、補助事業が支援されたプラスチックのリサイクル事業があります。その中からプラスチックから我々は水素を取り出しています。でですね、プラントの規模といたしましては、ウエストプラスチックが1日195トンパーで、大体200トンパーで、年間で6万トンぐらいのプラスチックを集めて、 そこからですね、1日水素換算で30トンパーで、これ我々はもともと2003年からこの事業を始めてて、主にアンモニアにしてましたけども、その一部をですね、クリーン水素としてこの実証事業として取り出してます。で、プラスチックから取り出した水素をですね、2つの主な利用先に使ってございます。一つは、パイプラインで、ホテルの前にですね、東芝、日本の東芝っていう会社のですね、燃料電池を置いています。この燃料電池の性能は、水素67リューベから100キロワットを発電しています。このホテルはですね、大体200室ぐらいあるですね、川崎の、羽田空港の前あたりにあるホテルとありますけども、200室ぐらいで大体300キロワットぐらい使えますので、3分の1をこのプラスチックからの水素の電気で賄ってございます。もう一つの利用方法はですね、トヨタの未来の絵がありますけども、プラスチックから出た、水素が、ISO のですね、FCB の規格に合致することを品質を確認しながら未来に詰めて運んでございます。我々はですね、これからもですね、その環境に優しい水素を作って、貢献しようと思ってございます。ただ、東芝の燃料電池はですね、まだやっぱ開発を終えた段階であってですね、コスト的にもまだ高いところがあったりとかですね、水素に関するですね、デバイスはまだまだコストダウンの余地があるのかなと思ってございます。プラスチックからの水素に関しましては、委託処理量がありますので、水素の変動費、コストに関しては、かなり経済性が見出せていると、そういう状況でございます。このプロジェクトはですね、2015年から5年間だったんですけども、2年間のエクステンションをもらってますので、あと約1年ありますので、さらに経済的に成り立つような水素実証ができたらなと思ってございます。発表は以上になります。ありがとうございました。
Thank you so much, Mr. Kuriyama. That was great. Up next, we have Grace Kwan, who's the CEO with Hydrogen in Motion. Ms. Kwan, over to you.
Hi, thank you for inviting me. Next slide, please. I'm President and CEO of Hydrogen in Motion. We're a Canadian company located in Vancouver. We've developed a nanomaterial that stores hydrogen under low pressure as a solid state. And so we've had, in a nutshell, a smaller, safer, cheaper tank. And we believe our breakthrough technology is the key to the hydrogen supply chain and will play a major role in growing the global market for hydrogen technology and hydrogen-based storage. Next slide. So why do you need something like this? The two big issues, as most people in this conference will already know, is that hydrogen stations and hydrogen storage and transport is costly, and with at high pressures, technically challenging to utilize. Next slide, please. Hydrogen in Motion, what we've done is we've made a nanomaterial that absorbs the hydrogen and keeps it on the surface material under 50 bar instead of 700 bar. It's physisorption, so it's not covalently bonded. And with the opening of the valve, it's able to release the hydrogen, no additional heat or catalyst is required. Just to let you know, we're going through these slides very quickly. Next slide, please. And you can contact me if you want a copy of the deck. We can use this. Our value proposition is that we reduce the CapEx cost of the hydrogen tank and reduce OpEx by simplifying the refueling at low pressure. We can open up markets like from small tanks for drones, etc., to swappable tanks to large volumes of hydrogen in a shipping container. Next slide, please. Of course, this is a very large market, can be used for distribution, fuel cell applications, and energy storage. And next slide. This is my contact details if anyone wants to reach out and talk more about what we have. Thank you very much.
I did it. I was muted. 2021. We're going to take our first break and hear from our expert commentators. So Ms. Horton, Mr. Gerard, and Mr. Kato, it's your turn to flip on your videos. And I think we're going to start with Francois and just some comments on what you've heard. And I will leave you to it. You are the experts.
Thank you so much. This is a very interesting set of presentations with the previous session as well as yesterday. And I want to touch on something that I've noticed in the strategy, and Jeff and his team has done a tremendous job for the Canadian strategy. And yesterday, Aaron Hoskin presented a bit more details. And we also heard about Japan's strategy. And one thing that I noticed was the development of hubs as a first take at it. As you know, we look at a hydrogen society or net zero by 2050 is very daunting. Maybe an area of collaboration could be about hubs exchange, the exchange between hubs that have a lot of commonalities. And one thing I noticed when I moved to British Columbia was seeing cities being twinned with cities in Japan. Maybe that's something that can be looked at to exchange lessons learned about how to make these hubs happen. The other one is codes and standards, harmonization. And I think that there's collaboration internationally through the IPHE, International Partnership for Hydrogen and Fuel Cell in the Economy, which also is looking at getting rid of the colors of hydrogen to focus on carbon intensity, which is very important, and we'll see that later. The other thing that I've noticed, and Grace's presentation highlights that hydrogen storage and transportation is critical. And there's a big need to find innovative solutions that could be also a topic of collaboration between the two countries. We can see that hydrogen production is happening in different ways for different regions. For Canada being a large country, having a lot of hydrogen produced today in the center of Canada, in the Alberta, Saskatchewan area, we need to be able to bring it to the point of use, whether it's British Columbia or Quebec or Europe or Japan, and find innovative and economical ways to bring it overseas. So I think I've seen a lot of potential collaboration in these areas. I will stop here to leave my colleagues to share their perspective. Thank you.
Well, I agree with everything that you say, and in particular, the focus on local level. I noticed both today in the presentations, but also in yesterday's discussion, that it's really at the local level that a lot of the experimentation is being done. So I would second that recommendation most definitively. I think also that we can, that Canada and Japan should be working on international collaboration as well. I know Japan has an agreement with Australia, but there are, I think, a lot of applications, for example, in Southeast Asia, where Japan is the largest investor. So when I was working in Japan in my previous life, we held a seminar on the hydrogen economy, and this was a long, long time ago. So I'm very happy that both Japan and Canada are very committed to net carbon zero by 2050. And I think we both agree that hydrogen is going to be a part of that. Showa Denko I worked with in Japan when I was working in advanced industrial materials. I'm glad to see that they are working with the city of Kawasaki. But yes, I think that their cities in Canada are also looking for both waste management and power generation solutions that will help all of the cities that are making commitments to net zero. And so to the extent that hydrogen can be a part of that, and it seems to me that hydrogen in motion offers some other potential solutions. And I think that there should be some interest in that in Japan as well, mainly because Japan has, from my experience, the companies in Japan are very well suited to working on materials. They have some of the best in the world, both on the metals and plastic side, and of course in transportation. And I'm really hoping as well, of course, that the Japanese auto manufacturers will start looking at Canada as for testing for some of their technologies that they are developing in Japan. So I will leave it there and turn it over to Kato-san.
While Mr. Kato's turning on his mute button, Francois, there's actually a question for you in the chat talking about the focus on hydrogen produced in Alberta and Saskatchewan. I wonder if you wanted to speak to that.
Oh yeah, absolutely. I've seen that too, and
don't need it with that sweater though. Don't need it with that sweater.
Oh, maybe Mr. Kato's available now.
I will be brief that
please, yeah.
that question speaks very well to the same issue. I refer to Alberta, Saskatchewan as most of the hydrogen produced today is coming from these provinces, but that's true that with hydroelectricity in Manitoba, Quebec, British Columbia, there is a case to be made to produce hydrogen. The challenges remain the same. That is how to transport safely that hydrogen to the points of use. And absolutely, it was not meant to diss any of the other regions.
I was sure that was the case. I wanted to give you a chance to respond there. Absolutely. Mr. Kato, are we able to hear from you?
はい、音声聞こえてますでしょうか。
Yes.
ありがとうございます。おっしゃる通り、エコノミーワイドでいきなり水素社会に変革するというのは難しいので、ローカルのそのハブとなるところの知見を共有していくっていうのは極めて重要というふうに思っております。で、先ほどご紹介になった昭和電工について言いますと、環境省の方で本通常国会にですね、廃プラスチックのリサイクルの法律案を提出してまして、日本としてサーキュラーエコノミーとカーボンニュートラル、これの両立を目指すということで進めているところです。中国などアジアでは、その廃棄物の輸出規制、輸入規制が進んでおりまして、国内でどういうふうに廃棄物をサーキュラーエコノミー構築していくかということがこれから重要になるというふうに思っています。で、これは海洋プラスチック問題の解決にもつながるということになりますので、そのような取り組みがますます重要になっていくだろうというふうに思っています。で、カナダ側の発表でトラックに使うというのは非常にいい取り組みだというふうに思いますし、急増合金の問題というのも、大変重要な問題だと思いますので、そのような知見を共有して、ノウハウを積み重ねていくということが大変重要だと思っています。以上です。
Wonderful. Thank you to all of our commentators. I'm going to ask you to flip back off. We're going to hear from you again. I'm going to save a minute or two so we can hear more from you after the next 3 presentations. And so I do want to shift to our next presenter now. That's Mr. Goto-Oda Leosuke. He's the Senior Project Manager of the Industrial Solutions and Service Business Division at Hitachi. So Mr. Goto-Oda, I know we're starting a little bit a minute or two before, but there you are. Fantastic. Over to you for your 5-minute presentation. Thank you.
ご紹介ありがとうございます。私、制作者の後藤田と申します。よろしくお願いします。我々、今、環境省さんから委託されている事業について紹介したいと思います。我々、宮城県の富谷市でですね、既存の物流網と純水素燃料電池を用いたサプライチェーンを実証しております。2017年からですね、製作所、丸紅、あと宮城生協、それと宮城県富谷市の4つのですね、共同事業者で実行しております。今、出しているスライドの上の方にサプライチェーンの概要を示しています。生協さんの物流倉庫にあります太陽光発電装置の電力を用いて、水電解装置で水素を製造し、その水素を急増合金に貯蔵します。貯蔵した水素急増合金は、生協さんの物流網を使って、一般家庭、あとはスーパーマーケット等にですね、設置してある燃料電池に供給されます。その燃料電池から、先ほどの水素急増合金から水素を取り出し、熱と電気を供給するというようなサプライチェーンになります。これまでこのサプライチェーンシステムを構築して、年間あたりどの程度の CO2 が下げられるかというところに対して、目標の 0.8 トンを満たせるということを実証してきました。このサプライチェーンの特徴は3つあります。下に書いてある通りですけども、1つ目が、まず水素を貯める装置として、水素急増合金を用いているということになります。左に黒い瓶みたいなのがありますが、これがキャニスターと呼ばれるもので、この中に急増合金が入っていて、ここに水素を貯めます。その3本のキャニスターを1つのカセットに入れて、配送するというものです。この特徴は、水素急増合金が非危険物として認定されていることになります。そのため、特別な資格は不要です。これまでのいろんなプレゼンテーションの中で、水素を貯める方式、あとは輸送する方式に対して技術課題があるということがありますが、我々はこの水素急増合金に貯めること、さらにですね、これが非危険物ということで、既存の物流網にこれを混載することで、輸送費のコストアップを低減するというところが大きな特徴だと思っています。で、2つ目の特徴です。真ん中です。こちらはですね、再生可能エネルギーの発電電力と需要の量を常時予測、モニタリングしながらですね、水素がどのタイミングで製造するのか、また、いつのタイミングでそれをデリバリーするのかというところを最適に制御するシステムを構築しています。で、3つ目の特徴です。こちらはですね、BCP 対応を、このサプライチェーンの中に、アドオンしています。低電池でも水素サプライチェーンが運用できることを目指し、今回我々は右の写真にありますような水素混焼ディーゼルエンジン発電機というものをこのサプライチェーンの中に、新たに設置しています。この発電機は水素とバイオ液体燃料を混合して発電するものです。ですので、この発電機はバイオマス発電として認定されています。また、発電だけではなく、発熱も可能ですので、コーディネーションとして使えるものと思っています。我々の元々のサプライチェーンは純水素燃料電池ということで、クリーンな水素で賄っていますけれども、過渡的な対応としては、このような水素混焼というものもですね、サプライチェーンとしては有効であると思っています。これまでエネファームと呼ばれる都市部に普及している燃料電池がありますが、我々のこのサプライチェーンは、LP ガスが普及している地域に対して、その代替のエネルギー向けサプライチェーンとして有効であると思っています。この事業、2021年度、来年度までの5年間の事業で、 実行することになっており、今後技術的、あと経済性の面でですね、さらなる検討を進めたいと思っています。私からの紹介は以上となります。ありがとうございました。
Thank you so much, Mr. Gotoda. Up next, we're thrilled to have Grant Strem, who's the chairman and CEO of Proton Technologies, join us. So Grant, over to you.
Thank you very much, Elizabeth. Thank you for inviting me to speak at this event. Are the slides up? Oh, here they come. Proton Technologies is a 5-year-old company with a method to make hydrogen in a way that, as far as I've seen, is the lowest cost, has the lowest carbon intensity by life cycle analysis, according to a study at the University of Calgary. And it also has the smallest ecological disturbance. And that's because it leverages existing assets that are already sites where development has occurred within the oil and gas sector. Next slide, please. The process is a combination of 2 older technologies. The first is injecting oxygen directly into an oil field. This has been done more than 500 times around the world, always with the goal to produce more oil. But each of those projects, as an accident on the side, always makes hydrogen. The hydrogen collects at the top of the oil field, inside below the seal, and then we have a hydrogen filter that only allows hydrogen to come through up to surface. And in that way, all of the carbon dioxide and everything else remains in the ground. The filters were developed within the steam methane reforming industry. Next slide, please. There are many very large oil fields around the world, and we feel that this energy is very easily accessible. Oil is hydrogen and carbon, and there's also water within these oil fields, H2O. So it's a hydrogen-rich, energy-dense, pressure-sealed gift of nature that we can go back into and collect only hydrogen from. Next slide, please. One thing that's nice about us, our process in comparison to steam methane reforming, is we never have to buy fuel. There are many oil fields and oil projects that have reached their economic limit and can be purchased at extremely low cost. So there's no fuel cost because our reaction vessel comes preloaded with this fuel. This also saves money on capital costs and operating expenses, and comes in the range of less than 20 cents per kilogram. Next slide, please. What we do have to build is an air separation unit. So we cool the air to -185, and then that's when the oxygen in the air turns to a liquid. This oxygen goes through a one-way valve out the side, and then we warm it up so it starts to flash back from a liquid to a gas, and that expansion gives it the pressure to go down into the oil field. This whole system can be powered by a portion of the hydrogen we make, and in that way has a very low, it can be a grid, its own isolated electrical supply for itself. Next slide, please. We have a project in Canada, and where we've been developing this technology through different milestones and different tests, and we'd like to scale up here. This very first project will probably only arrive at around 1,000 tons per day of hydrogen. But because there's such vast resources, using roughly 1/10 of Western Canada's oil resources, our math shows that we think that we could supply 10% of the world's energy for 50 years by 2040 through large-scale construction of many large air separation units. So that is our goal as a business. Next slide, please. It is difficult to supply 10% of the world market unless we can export off of North America. And this will require significant export hardware. So the very first thing that we intend to do in that regard is build a pipeline to the west coast of Canada, where at first we would it would be a hydrogen capable pipeline, initially carrying mostly methane for LNG shipments and some amount of hydrogen. And then we would grow the amount of hydrogen. And then maybe in 7 to 10 years from now, when there's more hydrogen carrier ships and our supply is larger, then we can start shipping only hydrogen as our export. Next slide. We have an advisory board that's very excited to help us reach our goals with a lot of history. And I talk about air pollution sometimes as a reminder of why I'm excited to do this. The next slide. I think air pollution is a crisis, and hydrogen from many different sources is going to play a significant role in getting rid of air pollution, saving us from unnecessary air pollution death. And that's all I have prepared to say. Thank you.
Fantastic. Thank you so much, Grant, for that call to action. And finally, we have Mr. Akiba Etsuo, Research Professor, Hydrogen Storage Division with the International Research Center for Hydrogen Energy at Kyushu University. Mr. Akiba, over to you for your presentation.
ご紹介どうもありがとうございました。皆さんおはようございます。九州大学の秋葉です。皆さんご存知のように日本とカナダは以前から共に水素エネルギーの研究開発を行ってまいりました。私自身の経験から言いますと、1983年から1年間、オタワの NRC でリサーチアソシエイトとして水素の貯蔵の研究をしたことがあります。たくさんの水素、大量の水素を海を渡って運ぶプロジェクトとしては、水力発電の電力で製造した水素をカナダからヨーロッパへ送るユーロケベックプロジェクトというのはかつてありましたし、日本でもウィネット計画というカナダの再生可能エネルギーで製造した水素を液体水素で日本に運び発電をするというプロジェクトもございました。現在はそういった大量の水素を運ぶプロジェクトが多く存在しているのはご存知かと思います。しかしながら私がこれからご紹介するのは、海を渡って大量の水素を運ぶのではなくて、地元にある地元の再生可能エネルギーから製造したグリーン水素を街中で必要な場所に効率よく配送し利用するサプライチェーンの実証事業です。これは観光予想の委託で2018年から4年間の計画で進めているところです。この事業は日本を代表するゼネラルコンストラクターの大成建設を代表に産学官の連携の下で進めています。場所は北海道の室蘭市という人口が8万人ぐらいの町で進めているところです。で、この事業の全体像をこのスライドに示しております。室蘭市の1000キロワット、1メガワットの風車からの電力を使って水素を製造します。水素の製造能力は電気分解により1時間あたり1立方メートル、すなわち1000リットルです。で、製造された水素は写真の左の下の方にある水素輸送トラックというか、これは水素吸増合金を入ったタンクを搭載した車ですけれども、これで運ぶことになります。で、強調したいのは、この水素製造場所で水素製造と水素をこの水素吸増合金タンクに充填するのが、すべて無人で行われているということです。で、ここで水素吸増合金について、前の講演でいくつかご説明もありましたけれども、私も簡単に説明したいと思います。水素吸増合金は合金の体積の1100倍から1500倍ぐらいの水素を、例えばすごい低い圧力、10気圧以下でも貯蔵することができます。言葉を変えますと、我々が持っている技術の中で最も水素をコンパクトにできるものと言えます。で、日本の法律や規制では10気圧以上が高圧ガスと定められていて、厳しい管理のもとに置かれます。また、建築基準法では、住宅地域への水素のような燃えるガス、可燃性ガスを貯蔵することは困難とされています。しかしながら、水素吸増合金を用いることで安全に水素を貯蔵できるので、これらの法律の規制を受けずに、建物や街中に水素を貯蔵し、有効に活用することができます。私たちの実証では、水素吸増合金 タンクはトラックで水素の利用先に運び、車の上に乗っている水素吸蔵合金タンクから利用先に置かれている水素吸蔵合金タンクへと水素吸蔵合金の間で水素を輸送されます。で、この時のスピードは1分間に1000リットルという非常なスピードで水素を移すことができます。で、この水素を使って燃料電池を用いて電力と熱を発生して利用先へ供給されます。2020年からは水素の配送先をもう1箇所増やしました。そこは通常は多くの市民が集まるセンターですけれども、災害が起きたときはボランティアセンターになる場所です。北海道では3年前に大きな地震があって、北海道全体で約3日間の間停電が続きました。私たちは災害に備えて新しく設置した燃料電池は停電の時でも運転が可能なものにしてあります。実際に、それまで停止した燃料電池は、停電があった時に問題なく起動し、災害時にとても有効なことを確認することができました。最初に申しましたけれども、この実証のリーダー企業は、ゼネコンである大成建設ですけれども、なぜゼネコンが水素のチャップライチェーンを実証するか、不思議に思われる方もおられるかもしれません。で、それは将来必ずや水素社会が実現し、建物や街中に水素が必要になってくるときに備えて、設計などのさまざまなノウハウを蓄積するために参加しています。我々はこのように安全に建物や街中に水素を普及するための実証を地域の皆さんと共に進めているところです。ご清聴ありがとうございました。
Thank you so much, Mr. Akiba. So let's once again hear from our expert commentators. I'll invite Mr. Kato, Mr. Gerard, and Ms. Horton to turn on your cameras and just provide some reactions, comments, opportunities for collaboration. And I think, Mr. Kato, we were going to hear from you first if you're ready to comment.
はい、環境省加藤です。ご紹介大変興味深いプレゼンテーションありがとうございました。特にグラントさんの地中から水素のみを取り出すというアイディアは大変ユニークなもので興味深いものだというふうに認識しました。日本側からの2つのプレゼンテーションのポイントは、その日本の家庭の半分はガスパイプラインにつながっているエリアということになりますが、日本の半分はガスパイプラインがつながってないエリアということになります。この人口がその密でない地域でどのようにそのエネルギーを供給していくか、エネルギーサプライチェーンを構築していくかっていうのは大変重要な問題だというふうに思っておりまして、その中で富谷市、室蘭のようなところで水素吸蔵合金を使ってデリバリーをするというのがどのような形でできるのかというのを検討を進めていきたいと思っております。で、北海道の方については地震でブラックアウト、停電などもございましたので、BCP、レジリエンスという観点からも水素をどういうふうに使っていけるのかというのが日本の国情として考えないといけないところだろうと思っております。このような取り組み、日本のマスコミ、テレビなども取り上げられておりまして、先ほどの昭和電工のようなものは、イギリスのスカイ TV などでも取り上げられておりますので、こういう日本のユニークな取り組みをカナダとも共有したいと思いますし、世界全体とも共有していきたい、このように考えております。私からは以上です。
Wonderful. Thank you, Mr. Kato. Deanna, over to you. Thoughts or comments?
Yes, I guess once again, I think, for example, if you take Muroran in Hokkaido, that's an excellent example of a demonstration project, academic, private sector, and government, which could be replicated not only in Canada and Japan, but in other countries as well. I would say the same thing for Proton Technologies in terms of the possibility of third country cooperation. Obviously, Japan does not have oil fields, but Japan works in a lot of countries that have oil fields, as does Canada. So perhaps we should be looking at this as on the possibility of collaboration in those countries. And I think, though, the other basic thing, and I think Francois mentioned it earlier, I'm very concerned about standards. And I think that was something that was mentioned yesterday. I used to work in technical barriers to trade. I know how important standards are. I think Japan and Canada should be gathering like-minded countries, because in order to develop this further, you need to have standards that are recognized by everybody. But on top of that, you want to have interoperability between all of the systems that are developed in Canada and elsewhere. And so having commonly agreed standards is going to be critical to that. So I think as a basis, that's something that Canada and Japan could take the lead and work very closely together, because I think it's in both of our interests that we develop solutions that can work not only in our countries, but around the world as well.
Wonderful. Thanks, Diana. And Francois, over to you. Last word.
Oh, wow. The pressure is on. Very interesting. I think the last words that I'd like to put is, well, first of all, I'd like to do a little publicity about NRC, as we do a lot of research on hydrogen. And the focus for the production side is to produce hydrogen without fossil greenhouse gas. So different ways using different feedstocks, water, natural gas, biomass. And so I really connected with the conversion of plastics to hydrogen. If I take Grant's presentation, what it highlights to me is that there is a lot of possibilities to produce hydrogen. This is one area. There's a lot of creative ways, and we need to look at commonalities where we can work together. Interestingly, what I have not heard was the use of geothermal energy, either in Canada or maybe Japan. I don't know if geothermal is predominant there, to power electrolysis. That would be another area of zero carbon. So I just want to leave there to say that I see a lot of possibilities. It's a matter of establishing those common points of contacts. And again, I want to reinforce that I do see this twinning of hydrogen valleys, as the Europeans call it, under Mission Innovation, to be a ground for collaboration between not only research laboratories, but governments and industries.
Wonderful. Thank you so much to all three of our commentators for joining us. You're free to go, turn off your videos, and please, I hope you join us in the networking spaces coming up right away. What an amazing last almost 2 hours we've spent. Fantastic to hear about the innovation underway on either side of the Pacific. Thank you to our speakers. Thank you to our commentators again. And of course, thank you to our wonderful audience for joining us for this second day of program. I want to remind you first about the networking space we shared with you on day one, which you can access in the link, on the link that's being shared in the chat and was shared earlier. If you didn't have a chance, make sure you hop in there. It's an online virtual whiteboard. You can add your contact information if you're comfortable, information about projects you're working on, and areas of collaboration that you might be interested in. So please hop in there. Now, we are, of course, happy to share with you 2 networking spaces, virtual networking spaces that you can join through Zoom, through the technology platform, to get to know one another a little bit better. So we're going to have 2 spaces you can join. The first is focused on the theme of building the supply chain, and the second on core technologies. So based on the responses that we heard from you in the registration, these were the 2 most popular groups that we had represented in the event. These rooms will have some moderators in them. In the Building the Supply Chain space, we're going to have Dr. David Lazell and Mr. Daniel Brock, two of our speakers from yesterday. So thrilled to have them back. And then in the Core Technologies room, we'll have Mark Kirby, who's the president of the CHFCA, and we'll have Francois Gerard and Grace Kwan, who were speakers today. So what you're going to see is these links showing up in the chat. You'll have your hosts waiting for you there to casually discuss the topics in the room, and you'll have a chance to get to know one another. We're going to open up those rooms in 5 minutes. So you have a chance to stretch, have a drink, go check on the kids, check on the pets if you're at home. When you click on the link, you'll find a new Zoom meeting launches. And in this one, you'll be able to actually turn on your camera and your audio so you can talk as a small group. And so be sure to flip on your camera and unmute yourself when you join the room so that you can interact. These rooms will also have interpretation. So you'll again see the globe icon at the bottom of your screen so you can select your preferred language. So to those of you planning to join the networking rooms, absolutely enjoy. To all of you, thank you for joining us over the last couple of days. I sure hope this event was insightful and meaningful for you. I want to thank our hosts, Environment Canada and the Government of Canada, and of course the Government of Japan for all of the great work that you did to bring this event together. Thank you for allowing Globe Series to be part of it. Again, I'm Managing Director with Globe, and it's been such a privilege to work with you and your teams. So be sure to engage in the Canada-Japan Hydrogen Networking Board that we shared yesterday. Please do join those networking spaces. They'll be open again in about 5 minutes from now, and we will see you there. Have a wonderful day, stay safe, stay well, and take care.